the facts and info on everything about prehistoric animals. animals. So, today I'll be diving into the mammoth, one of the Ice Age's most famous and iconic mammals. Just by the way, if you want to catch more of my videos, subscribe, leave a like, and a comment, and follow the Animal Adventure channel, not on YouTube, as well as Animal Online Guide. And a massive shout out to those people who are currently watching my videos and subscribing. Thank you. And yeah, if you, like I said, if you haven't subscribed, smash that subscribe button, leave a comment and a like. And what's on the agenda for today? We'll begin with an introduction to mammoths, then dive into their evolution and species diversity. Then after that, we will explore their habitat and lifestyle, followed by the extinction and science discoveries, and end everything off with with mammoths in modern science and culture. In this section, we'll begin by defining the mammoth and their place in the animal kingdom. Then we will explore their distinctive physical characteristics and end with comparisons to modern elephants. They belonged to the Elephantidae family, which involved your mastodons and your modern elephants, such as your Asian and your African. Okay. Now, the genus is mammoths, which included your Columbian mammoth. And they were herbivorous mammals that roamed the Pleistocene epoch until their extinction around 4,000 years ago. Uh, as proboscideans, they share distinct trunk and tusk features characteristics of this order, positioning them as iconic representatives of the Ice Age megafauna. Now, mammoths were very easy to identify due to their long curved tusks, domed skulls, and thick fur, adapted to the cold. Some species, like the woolly mammoth, had fur up to 90 centimeters long and subcontinuous fat layers for insulation. Their molars were adapted to grind tough fibrous plants materials, reflecting their herbivorous diets during the Ice Age. While mammoths and modern elephants, such as your Asian and your African elephant, shared a common ancestor, mammoths generally had adaptations which allowed them to adapt to colder environments, including more fur, smaller ears to conserve heat, and differently shaped tusks. Genetic studies indicate diverging lineages about 6 to 5 million years ago. Behavioral similarities are noted, though mammoths appear to have had slightly different social structures due to the Ice Age ecological pressure. This is the section that we explore their diversity as a species and their evolution. In this section, we will begin with their origin and evolution lineage, then dive into the major mammoth species, adaptations to, and end off with the adaptations to the Ice Age environments. Mammoths evolved from primitive proboscideans in Africa around 5 million years ago, spreading into Eurasia and North America. Fossil records and DNA analysis reveal a sequence of species showing gradual adaptations to cooling climates during the Pleistocene. This evolutionary lineage highlights diversification, leading to distinct species like woolly mammoths and Columbian mammoths. Two of the key species of mammoths were the woolly mammoth, Mammoth primigenius, and the Columbian mammoth, Mammoth columbii. Each adapted to different regions and climates. Woolly mammoths inhabited colder tundra regions, while Columbian mammoths thrived in North American temperate zones. And species size ranged from 2.6 to 4 meters tall at the shoulder, highlighting significant diversity. So, in order to deal with the cold, mammoths developed a dense underwall and guard hairs with large fat deposits and a specialized hemoglobin. Skeletal features such as shorter limbs and tail minimize heat loss. Behavioral adaptations likely included migration patterns to exploit seasonal vegetation. These traits illustrate evolutionary response to the extreme glacial environments characteristics of the Ice Age. Habitat and lifestyle. In this section, we will discuss their distribution across continents, diet and feeding behavior, and end off with their social structure and behavioral patterns. Now, mammoths roamed widely across North America, Europe, and Asia during the Pleistocene era. The woolly mammoth was more adapted to the tundra steppe biome of northern Eurasia and Alaska, while the Columbian mammoth inhabited more temperate zones in North America. Fossil finds and preserved remains indicate migration corridors and range shifts linked to glacial and interglacial cycles. Okay. It was believed that a mammoth's diet was consisted of grasses, sedges, shrubs, and other tundra vegetation. The dental morphology with rigid molars shows that their teeth were adapted for grinding tough fibrous plants. Isotope analysis remains reveals seasonal variations in diet correlating with migrations and vegetation availability. Their grazing displayed an important role in shaping the Ice Age ecosystem by maintaining grassland expanses. Evidence from fossil sites and analogy with uh, modern elephants suggest mammoths lived in complex social herd structures. Group sizes often varied, but likely provided protection and cooperative of caring for young. Behavioral interference from trackways and kill sites indicate coordinated movement and possibly communication through vocalization and tactile signals. Right. Extinction and scientific discoveries. In this section, we will explore the possible causes of extinction, discoveries of mammoth remains, and lastly, will dive into the role of mammoths in paleontology. So, the mammoth's extinction is attributed to a few key things. One is climatic warming, another is the end of the Pliocene era, then another is habitat loss and overhunting by humans. Evidence supports a complex overlay where reduced habitat from warming trend, trends coupled with human pressure cause, cause population declines and accumulating in extinction. Some populations survived on isolated islands until about 4,000 years ago. Remains of mammoths have been uncovered since the 17th century, with significant finds preserved in permafrost, providing rare insight into mammoth biology. Some notable discoveries include frozen carcasses with preserved soft tissue and stomach contents, enabling data extract and advanced study. These finds expanded the knowledge about the Pleistocene ecosystem and mammoth physiology. Mammoths have been central to understanding the Ice Age environments, extinctions, and megafaunal interactions with humans. They serve as a model species for evolutionary biology, genetic, and climate studies. Research on mammoth advances methods such as ancient DNA recovery and radiocarbon dating, underpinning broader paleontological knowledge. Mammoths in modern science and culture. In this section, we will explore the efforts in de-extinction and cloning representation in art and folklore, and end with significance in contemporary research. Recent advances in genetic engineering and cloning have spurred efforts to reconstruct mammoths or mammoth-like elephants by editing genes from preserved specimens. Projects aim to reproduce traits like cold tolerance to Asian elephants to restore tundra ecosystems. Ethical and ecological debates surrounding feasible biodiversity impact and conservation priorities. Mammoths have featured promptly in prehistoric cave paintings, indigenous myths, and modern popular culture as symbols of Ice Age life and mystery. Their enduring presence in folklore reflects human fascination with prehistoric megafauna and the impact of their extinction on cultural memory. Artistic depictions emphasize the grandeur and enigmatic nature. Mammoth studies inform climate change research, megafaunal ecology, and evolutionary biology. Insights from their extinction help model current biodiversity loss patterns. Additionally, mammoth genetic aids conservation biology by revealing adaptation mechanisms to changing environments, serving as a window into the past and future ecosystems dynamics. In summary, mammoths offer invaluable insight into Ice Age ecosystems, evolutionary biology, and extinction processes. Their legacies continue to impact scientific research and cultural narratives today. By studying these majestic creatures, we deepen our understanding of the natural history and explore possibilities in modern science and a de-extinction effort. Unfortunately, that's the end of our episode. Thanks for watching. If you haven't smashed that subscribe button, please do so. Every subscriber counts. And you can also check me out on the Animal Adventure Channel podcast, as well as the animal recordings to find out what they sound like. Some of them might shock you. Or go to my Facebook page, Animal Adventure Channel 23 on TikTok, and Animal Adventure Channel with underscores between on on Instagram.